Today we are going to discuss one application of law of conservation of linear momentum. Can you remember the law of conservation of linear momentum? The theorem states that in an isolated system, that is, in absence of external force, total linear momentum of the system remains constant. Okay? By using that theorem, we want to discuss why the gun recoils in opposite direction during firing of the bullet, and what force is required to fire the bullet with the help of this gun. Let capital M is the mass of the gun, small m is the velocity, small m is the mass of bullet. Capital M to mass of gun or small m to mass of bullet. Before firing, bullet are inside the gun and gun is at rest. So, what is initial velocity of bullet before firing the bullet? Initial velocity of the bullet is 0. What is initial velocity of the gun? It is also 0. Therefore, initial momentum of gun is 0 and initial momentum of bullet is also 0. Capital M into 0 plus small m into 0. This gives you initial momentum of bullet and gun before firing. This is equal to 0. When we fired the bullet, what happens? Bullet moves in forward direction with velocity small v. When we fire the bullet, the bullet moves in forward direction with velocity small v. So this is final velocity of the bullet. Let capital V is equal to velocity of gun. We have to calculate in which direction the gun moves. Let capital V be the velocity of the gun. So what is initial momentum of bullet? Mass of the bullet into velocity of the bullet, small m small v, small m small v. What is the final momentum of gun? Mass of the gun into velocity of the gun, capital M capital V. So final momentum of gun and bullet is equal to small m small v plus capital M capital V. What is law of conservation of linear momentum? What is the law of conservation of linear momentum? The linear momentum, law of conservation of linear momentum states that in absence of external force, initial momentum of gun and bullet is equal to final momentum of gun and bullet. Initial momentum of gun and bullet is 0. Final momentum of gun and bullet is this, small m small v plus capital M capital V. Since initial momentum of the gun and bullet is 0, from conservation of linear momentum, final momentum must be 0. Therefore, small m small v plus capital M capital V is 0. Therefore, capital V is equal to minus small m small v divided by capital M. So this negative sign shows that the gun move opposite to the direction of the bullet. Again you see the velocity of the gun is inversely proportional to the mass of the gun. So more the mass of the gun, less the velocity of the gun. That is why mass of the gun is much larger than the mass of the bullet. Mass of the gun is much larger than, so therefore velocity of the recoil of the gun is very less. Now we want to calculate the force needed to keep the gun in position. Small n, number of bullets fired in 1 second. Number of bullets fired in 1 second is equal to small n. Do you know Newton's third law? Every action has an equal and opposite reaction. During firing, we apply force on the bullet. During firing, we apply force on bullet. So that is action. As a reaction of this, bullet exerts a force on the gun, due to which the gun recoils in opposite direction. Force on bullet is in forward direction, so therefore force on gun is in reverse direction. So therefore, to keep the gun in position, we have to apply a force on the gun. Therefore, to keep the gun in position, we have to apply a force on the gun. Therefore, force needed to keep the gun in position is equal to force on the gun. Force on the gun is equal to force on bullet. বুঝি পাইছা না? Force needed to keep the gun in position is equal to force on gun. Force on gun is equal to force on bullet, according to Newton's third law. What is force on bullet? Force on bullet is equal to rate of change of linear momentum of bullets. Force on bullet is equal to rate of change of linear momentum of bullets. What is Newton's second law? Applied force directly proportional to the rate of change of linear momentum of the body. Is not it? Therefore, rate of change of linear momentum of bullet is equal to change of linear momentum of bullet divided by time. Divided by time for that change. What is change of linear momentum of bullet? Final momentum of bullet minus initial momentum of bullet. What is final momentum? Small m, small v. What is small v? Is the velocity of bullet after firing. What is small m? Mass of the bullet. This gives you the final momentum of bullet. Small m into 0, this gives you initial momentum of bullet, because initially bullet is at rest. So therefore this equation gives us, এই ইকুয়েশনটো আমাক কি দিব? এই ইকুয়েশনটো আমাক দিব, this equation gives us change of linear momentum of bullets divided by 1 by n. What is 1 by n? Let n bullets are fired in 1 second. N bullets. Let n bullets are fired in 1 second. N bullets are fired in 1 second. So what is time required to fire one bullet? So 1 by n second. Is it clear to you? In 1 second, n bullets are fired. So therefore time for firing of one bullet is 1 by n second. Is not it? Therefore, small m small v minus 0 divided by 1 by n gives you rate of change of linear momentum of bullet. This is equal to 0. This is equal to 0. N will go in the numerator. Therefore, F is equal to NMV. This gives us force needed to keep the gun in position. This equation gives us the force needed to keep the gun in position. Now, we want to discuss one numerical. A gun of mass 10 kg fires 35 gram bullet with a velocity of 500 meter per second. A gun of mass 10 kg fires bullet of mass 35 gram with a velocity of 500 meter per second. If the gun fires 7 bullets per second, if the gun fires 7 bullets per second, if the gun fires 7 bullets per second, we have to calculate the force needed to keep the gun in position. We have to calculate the force needed to keep the gun in position. And number 2, the velocity of recoil of the gun. Again, I repeat the numericals. A gun of mass 10 kg fires bullet of mass 35 gram with a velocity of 500 meter per second. And the gun fires 7 bullets in 1 second. We have to calculate the force needed to keep the gun in position and velocity of recoil of the gun. So we may calculate it from this equation. What is the force on gun? Force on gun is equal to force on bullet. Force on gun is equal to force on bullet. What is force on bullet? Force on bullet is equal to rate of change of linear momentum of bullet. What is rate of change of linear momentum of bullet? Change of linear momentum of bullet divided by time. Rate of change means ki change of linear momentum of bullet divided by time required for that change. In 1 second, how many bullets are fired? 7 bullets are fired. So what is time for? Time required to fire 1 bullet? 1 by 7 seconds. In 1 second, 7 bullets are fired. Therefore, time needed to fire 1 bullet is 1 by 7 seconds. What is change of linear momentum of bullet? Final momentum of bullet minus initial momentum of bullet. What is initial momentum of bullet? Mass of the bullet into initial velocity. What is initial velocity? 0. Because initially bullet is at rest. Bullet is inside the gun and gun is at rest. So initial momentum of the bullet is mass of the bullet into velocity of the bullet. And what is mass of bullet? 35 gram. Convert it into kg. So 0.035 kg. 0.035 kg. Because 1000 gram is 1 kg. Therefore 35 gram is equal to 0.035 kg. What is final momentum of bullet? Mass of the bullet into final velocity. What is mass of bullet? 0.035 into 500. So this equation gives us, this numerator of this equation gives us change of linear momentum of bullet. This is time required for change of time required to fire 1 bullet. So therefore, this equation as a whole gives us the rate of change of linear momentum of bullets. This is equal to 0. 0.035 into 0 is equal to 0. So 7 will go in the numerator. So we are getting this. Now we want to calculate recoil of the gun. In order to calculate recoil of the gun, we have to apply law of conservation of linear momentum. Law of conservation of linear momentum states that initial momentum of the system is equal to final momentum of the system. In our system, there are two bodies. One is gun and one is bullet. Initially, both the gun and bullet are at rest. Therefore, initial momentum of the gun and bullet is equal to 0. This is the mass of bullet. This is initial velocity of bullet. This is mass of the gun. This is initial velocity of gun. So therefore, if I multiply these two, this is equal to 0. This is mass of the bullet, final velocity of the bullet. So this gives us final momentum of bullet. This is mass of the gun. This is final velocity of the gun, which we have to calculate. Let capital V be the velocity of recoil, velocity of the gun after firing the bullet. Capital V be the velocity of gun after firing the bullet. I don't know what is the value and what is the direction. So then V gives us final momentum of gun because mass of the gun is 10 kg in this numerical. So left hand side is 0. So therefore, if I do the calculation, capital V comes out to be this. So this is called velocity of the recoil of the gun. So this negative sign implies that the gun move opposite to the direction of the bullet. So instead of calculating or instead of solving the numerical in this way, we may directly use the formulas that we discussed. Instead of calculating or instead of solving the numerical in this way, we may directly use the standard equation. What is the force needed to keep the gun in position? NMV. What is N? Number of bullets fired in 1 second, which is 7. What is small m? Mass of the bullet, 35 gram. Convert it to kg, 0.035. What is small v? Final velocity of the bullet, which is 500 meters. So if I multiply all this, it is 122.5 Newton. So this is the force needed to keep the gun in position. What is the standard equation of velocity of gun? Capital V is minus small v divided by capital M. You put the value, small m 35 gram, mass of the bullet 35 gram. If I convert it to kg, 0.035. Small v, velocity of the gun. Capital M, mass of the gun. Yet given over small m to over 0.035, it will keep mass of bullet. 500 to keep final velocity of the bullet. Or capital M to keep 10 kg, mass of the gun. If I do this, it is this. Okay?